Hi, welcome to latent variable estimation using Gaussian mixture model. Here we are going to implement the Gaussian mixture model by using expectation maximization algorithm. The Gaussian mixture model contains the data from different distributions. Like you look at that in the diagram, we are having two distributions with mean value 10. One distribution is there, so it will be like look like this, and with the mean value 20 we are having another distribution, it will be look like this. So the data available in this location belongs to two distributions, so we have to identify the each data point available in this area belongs to the particular distribution. So that is the aim of Gaussian mixture model. Here the Gaussian mixture model is having two parameters, mean and standard deviation for each and every probability distributions. Initially, we will assign the parameter value mean and sigma with randomly, and in expectation step, we will compute the value for latent variable. Latent variable in the sense in clustering, we will not have the actual label for the given data set. So that actual label is called here latent variable. The label should be identified by using the GMM model. So the GMM model will identify for each data point belongs to some specific clusters. So this data point will be identified as the group of data like this. So the specific clusters will be identified here. Then once identify the cluster, then in maximization step we want to update the this parameters. Already initially we have assigned random numbers, so we want to get optimized parameters to improve the performance of our model in maximization step. So after updating, again we have to compute the cluster. Again we have to compute the cluster with new parameters. Again, we have to update the parameter in the second iteration. So we have to keep on compute the cluster and update the parameter. Again, compute the cluster and update the parameter until we are reaching the convergence. That means the data points belongs to specific clusters. So this is the uh, algorithm of GMM. Now we will see the example of expectation minimization algorithm here. So for that we are having Jupyter notebook with code. Here I am calling the data set from the, I am creating the data set from the blob, and I am using the statistics variable from the SciPy, and here I am importing the numpy package. Then here you look at that, here I am using cluster standard deviation. Standard deviation is 1, and I am creating the cluster data set randomly. Then here number of samples, here number of samples I am creating 12,000 for a data set. Then I am using three distributions I am going to use. So based on that, I am creating the two columns of data. So one is the feature and another one is the for reference label. Then here the x is assigned with some features by using the random numbers here, which is assigning two columns. Then I am creating the matrix by sorting that numbers. So already I am having the two features, the zeroth column and first column. I am sorting that numbers in ascending order. Okay, I am sorting that numbers in the ascending order. So then just I am checking what is the length of given data set x, that means features, that is 12,000 samples available in the x, and y also 12,000 samples available, so it is matching. Then just I am printing the x and y values. It's look like array value. So now I'm concatenating the x and y, just I'm flattening. That means there is two features available, two columns. The two columns are converted into single vector, single vector by using the flattening method. Then after that I am transposing that. So finally I am getting, so here x is 12,000 length and y is 12,000 length. So 12,000 into 12,000 I am getting the value, that means number of samples. Then these are the number of samples in the x and y. Here I am importing the, so now we got the data set. We got the data set x with 12,000 samples. 12,000 samples. The number of distributions are 3. Number of distributions are 3. Then now I am importing the Gaussian mixture model. Here Gaussian mixture model is having two steps. One is in expectation step. There we will add the data point to a specific cluster. Then we will estimate the parameters which are belong to the Gaussian distribution, mu and sigma. So here mu is the mean and sigma is the standard deviation. So we need the we need the two parameters. So here I am taking three components. That means number of distributions in our data set is 3. Then I am fitting that, training the model by using the data set x. Just we are printing the convergence. Is it converged or not? Yes, it is converged. Then we are identifying the mean values and sigma values. Mean values and sigma values. Here then I am predicting the value for 0.5 and 0.5. Here, which is predicting the probability score for the each sample. Here the probability score for that, cluster centers, it's like a cluster center. So these are the three cluster centers for each group. Then finally we are displaying the data. So this is the plot size, 12 pixels. 12 width is 12 and height is 12. Then dpi, the depth for inch is 100. Then we are splitting that plot. Actually we are not using here that plot is single plot, single row and single column. And we are using the x of 0 and x of 1 because we need two features for displaying the data. 0th column and first column, x1 x2 features. Then I am using clusters. Here we are using 0.5, the range 0.5 and 0.5. There we got the clusters, three cluster centers. So that cluster centers will be in the color of orange. So that is given here. You look at here, three clusters, cluster 1, cluster 2 and cluster 3. So we have got three clusters. Then by using the different means and different sigma value, we are going to calculate the cluster size with respect to x1 feature and x2 features. Here that contour lines, that cluster size is indicated by using the black color. So that's what given here. You look at that each cluster is having the contours. This is the cluster size, which is what do you call, which is improve, I mean maximizing the size of the clusters. Maximizing the size of the clusters. Look at here. Here also these are the data points overlapping. So these are the data points overlapping in this distribution. So here the Gaussian mixture model identifies the different groups by using the EM algorithm. So this is the way to implement the EM by using GMM model. So here the EM is deciding the sigma value and the mu value in the background. Thanks for watching.